Algebra 2 Honors, 9.3, Day 1, and we're going to go back and pick up one type of problem from 9.1. And so we are going to be defining the 6 trig functions on a circle using x, y, and the radius, and evaluating the 6 trig functions. So here we have the general definitions, and this is when we have a point on a circle, and the equation of that circle is x squared plus y squared equals r squared. Remember, r is the length of the radius. And so if I go to a point on that circle, that point is going to be the ordered pair x, y. And the length from the center to where that point is going to be the radius length of that circle. And the radius is always going to be considered to be positive. Of course, x and y in quadrant 1 are both positive. In quadrant 2, the x is negative, the y is positive. In quadrant 3, both x and y are negative. And in quadrant 4, x is positive, y is negative. Again, r will always be positive. And so sine ends up being y over r. And cosine ends up being x over r, and tangent ends up being y over x. And the idea is, let's just take a different circle here. And if I draw to this xy point and drop a right angle, so this is my radius. If this is my angle that I'm referring to, then this is my adjacent side, this is my opposite, and r is my hypotenuse. And so sine of theta is that opposite over the hypotenuse, but the opposite is y and the hypotenuse is r. So sine is going to just be y over r. Cosine is your adjacent over your hypotenuse. But in this case, that is your value of x, and then the length of the radius is r. And tangent is opposite over adjacent, and so the opposite is your y value and your adjacent is your x value. So tangent always ends up being y over x as long as x isn't 0. You can't divide by 0. So we are just referring back to the SOHCAHTOA definitions that we had before, but we're looking in terms of, the opposite side in this case is y, the adjacent side is x, the hypotenuse is r. And then, of course, we have the reciprocal functions. Remember, sine starts with an s, its reciprocal starts with a c, so cosecant is your radius over y, and secant's radius over x, and cotangent is x over y. And they just mentioned that these are sometimes called circular functions. So we are going to use these definitions given this information that we have in example 1. It says, let 8, -6 be a point on the terminal side of an angle in standard position. So up above here, we had this angle in standard position, and then we are just saying that we have an xy ordered pair here that intersects that circle. So let 8, -6 be a point on the terminal side of an angle in standard position. And so we are going to draw a diagram where that happens. And since this is where x is positive and y is negative, we're going to be in quadrant 4. So draw a diagram. You need to have a diagram on these. Now, one diagram is going to suffice for all 6 of our trig functions. But we're going to go to the right 8 and down 6. So I'm going to create a triangle. This is going to be my reference angle. And I'm going to the right 6 and I'm going down, or to the right 8 and down 6. And then we're going to find the radius length by using Pythagorean's theorem. And instead of calling it the hypotenuse, we'll just call it r for the radius. And if you solve that out, you're going to get 100 is r squared, but remember I said r is always positive, so the hypotenuse is going to be 10. So we have this xy ordered pair to the right 8 and down 6. That means x is 8, y is -6, and r is 10. And then we're just going to remember that sine is defined to be y over r. And so the sine is going to be the y value over the radius, and then reduce it, and we have a -3/5. So you plot the point, you assign those values to the sides of the triangle, you find the radius, be sure to draw the triangle in the correct quadrant, and then use the definitions that you see up above to give the values of all the 6 trig functions. So we have sine is -3/5. So then how about if we do the cosecant next, because that's the reciprocal of sine. And so that's going to be a -5/3. And typically I put the negative out in front. I don't put a negative in the denominator. Cosine is your x over your radius. You want to know these definitions. And your x coordinate is 8 and your radius is 10. And that reduces to 4/5. So you always want to reduce, and you have to rationalize the denominator when needed. The reciprocal of cosine starts with c, its reciprocal starts with s, it's secant. And so the secant is going to be 5/4. Tangent is y over x. And so that's going to be -6/8. And that will reduce to a -3/4. Be very careful that your negative signs don't get lost and mixed up with your equal signs. A reciprocal of tangent is cotangent. So the cotangent is going to be a -4/3. So I suggest you pause and you try the next one. Make sure that you rationalize the denominator. Let's see how you did. If I'm going left 4 and down 6, that's going to be in quadrant 3. So I'm going to draw that triangle in quadrant 3. Left 4 and down 6. And so left 4, down 6. And then for the radius, -4 squared plus a -6 squared equaling the radius squared. You have 16 plus 36 is 52. And 52 is 4 times 13. And so that radius is going to be 2 square root of 13. So you need to simplify the radical. And then now I know that for this ordered pair, I'm left 4, down -6. That means my x value is -4, my y value is -6, and my radius is 2 root 13. So sine is going to be y over r. It's going to be a -6 over 2 root 13, which is going to be a -3 over root 13. And rationalize is a -3 root 13 over 13. You need to show some work on that. And then the reciprocal of sine is cosecant. And so I would be thinking about this form, the form before you rationalized, because when I flip it, the denominator will be rationalized. So it's a -root 13 over 3. Cosine is x over r. It is your -4 over 2 root 13, which is a -2 over root 13. So rationalize, it's a -2 root 13 over 13. And that's your cosine. The reciprocal of that secant And again, I would be thinking about this one, the one before rationalizing it, and flipping it will make it a negative root 13 over 2. And then tangent is your y over your x. So that's negative 6 over negative 4. So it comes out positive 3/2. And just leave it improper. And then its reciprocal will be 2/3. So use those definitions. You want to just know those definitions and evaluate. All right, so then we have a special circle, which is called the unit circle. And it's a unit circle because its radius is 1. So that equation there, x squared plus y squared equals 1. That 1 is your radius squared, so your radius is 1. Now, we're going to be using the unit circle more in upcoming problems, but for this lesson, the only angles that you are to use the unit circle for in 9.3 are what we call quadrantal angles. It's an angle in standard position whose terminal side lies on an axis. So it's always, a quadrantal angle is always a multiple of 90 degrees. So the terminal side is going to intersect and end at 0, 90, 180, or 270. They're multiples of 90. So multiples of 90 are going to, so 0 degrees, 90 degrees, 180 degrees, 270 degrees, and a full rotation of 360 degrees. Or in radian values, 0, pi halves, pi, oops, 3 pi halves, and 2 pi. Of course, we can rotate a negative, or we have a negative angle and rotate clockwise as well. It's just a matter, do they end up in one of these 4 spots? Because then we don't really end up with a triangle. So they're going to be a little bit different in terms of how we handle them. And so they kind of try to prep you for that right in here. Since we just found out that sine is defined to be y over r, on the unit circle, it's special because the radius is always 1. So on the unit circle, if we know we're on the unit circle, the sine simplifies to just the y value. Same thing with cosine is x over r, but because the radius on the unit circle is 1, cosine ends up just being the x value. So if I'm thinking about this point right up here, which is xy and x and y, well, since it's the unit circle, you didn't go to the right or left any, you went up 1. I know x is 0 and y is 1. And so we're saying if you're on the unit circle, then the sine of 90 degrees is just the y coordinate. The cosine of 90 degrees is just the x coordinate if you are on the unit circle. So we kind of started that. This is a jump on this next example here. And just a second. Oh, yeah, I was wondering, I grabbed the wrong, I grabbed last year's, and so this homework is just a little different. I downloaded the wrong one. Let me just check that real quick and get you the right homework on that. I just grabbed last year's instead of this year's. I will change that for you because I noticed I had some other things written in and they're missing on these. So this is 5, 6, 8, 10, 12, 14, 15 through 22. And I still want you to do page 467, 41, and 45. So we just shortened this one a little bit. And I just noticed it because on your template, I filled some more things out when we got down to example 2. And so on here, use the unit circle to evaluate the 6 trig functions. And the only times we're using the unit circle is if we end up at one of these angles. And so they want you to do this for 90 degrees. So it's important when you write this that you put the 90 degrees in as the argument. So we're going to have sine of 90 degrees. It's reciprocal cosecant of 90 degrees. And then I'm going to have you evaluate cosine of 90 degrees. And it's reciprocal, which is secant. Make sure you put the degree symbol on that. And then tangent of 90 degrees, and then cotangent of 90 degrees. And so draw a diagram. So I want you to draw a unit circle, or attempt to. Okay, there's my attempt. And if it's 90 degrees, then the initial side is on the positive x-axis, but we're rotating 90 degrees, and we're going to treat this as the unit circle x squared plus y squared equals 1. So this ordered pair is 0, 1, meaning x is 0, y is 1, and you're on the unit circle, so the radius is always 1. So as we saw up above, sine simplifies to just be the y coordinate. Cosine simplifies to just be the x coordinate, which is 0, when you are on the unit circle. Tangent is y over x, which is a 1 over 0. You cannot divide by 0, so you must say that it's undefined there, and I just write UND, undefined. You can't leave it 1 over 0, you won't get credit for that. So the cosecant ends up then being 1 over y, because it's the reciprocal of sine. And since y is 1, it's 1, and the reciprocal of 1 is 1, so it makes sense. The secant ends up being 1 over x, but the x is 0. You can't divide by 0, so the secant is undefined. And cotangent is x over y, and so that is going to be 0 over 1, and that simplifies to 0, and you need to write 0. You can't leave it 0 over 1. So why don't you try it? Try it with a negative 5 pi halves and see how you do. How did you do? I'm just filling this in. You need to make sure you put your angle. This is called the argument. This spot is called the argument. You need the argument of the sine, cosine, tangent functions. Lots of times I'll see when people start doing these, they'll forget to put in that argument. You need that angle in there. And so when we draw the diagram, we need to figure out that negative 5 pi halves is a negative 4 pi over 2 plus an additional negative pi halves, meaning this is a negative 2 pi, which is a full rotation clockwise, and then a quarter of a turn, a negative pi halves. So, whoops. All right, so there's my circle, and I'm going to draw that in. So I am rotating clockwise, a full rotation, and then ending up here at 90. So that terminal side is intersecting the unit circle. So this point is 0, negative 1. So my x is 0, my y is negative 1, and my radius is 1 because we're on the unit circle. Again, to evaluate these quadrantal angles, we're going to use the unit circle where the radius is 1. So sine of negative 5 pi halves is just the y value, which is negative 1. Cosine is the x value, which is 0. And tangent is y over x, which is negative 1 over 0. And we have it is undefined again. The reciprocal of sine is cosecant of negative 5 pi halves. And the reciprocal of negative 1 is negative 1. Again, it's 1 over y, which is 1 over negative 1, which is negative 1. Cosine, the reciprocal is secant. But the reciprocal of 0 is going to be 1 over 0, which is going to be undefined. You can't divide by 0. And then for cotangent of a negative 5 pi over 2, it's the reciprocal of tangent. It is x over y. It is 0 over a negative 1, and you need to simplify that to 0. You don't get credit for 0 over negative 1. Now, a big topic is reference angles. And so a reference angle is an acute angle with the vertex at the origin. One side is the terminal side of the angle in standard position. The other side is either the positive x-axis or the negative x-axis, whichever one will create an acute angle. The acute angle is an angle between 0 and 90 degrees, or if you're in radians, between 0 and pi halves. The notation is, we call that theta prime. That's your notation for the reference angle. I've also seen reference angle with a bar over it, so that could be a possible other notation. All of this is no calculator up here. No calculator, no calculator. None of this is calculator. Oh, and on the new notes I put in here, I just grabbed the wrong file for them. So no calculator, no calculator. This is stuff that you just need to know and have a way to develop. All right, so if an angle is given in degrees, give the reference in degrees. If the angle is in radian measure, give the reference angle in radian measure. These are all going to be things I'm looking for. So first of all, graph it in standard position. So we're going to go to this negative 220 degrees. And I'm thinking, well, that's a negative 180 degrees, and it's going to be an additional 40 degrees just to kind of figure out where we're going to end up. So as I go to graph this in standard position, start here, and I'm going to go a negative 180 and 40 degrees more. So the reference angle is the angle that the terminal side is one side, its vertex is the origin. So here's my terminal side, so that's one side. And it's either the positive x-axis or the negative x-axis. And it will, in this case, be the negative x-axis. Because then those two create this angle here, and that angle is acute. And you need to figure out the value. The reference angle is always going to be between 0 and 90 degrees, or between 0 and pi halves. And so this goes to, we went 180 degrees, and then we had to go an additional 40 degrees. That angle, that reference angle, is 40 degrees, right? 220 degrees minus 180. I went past 180, 40 degrees. So my reference angle, theta prime, is 40 degrees. Don't forget your degree symbol. All right, then we have 15 pi 16. So part of this is fractions, part of this is knowing radian values, et cetera, et cetera. But I'm thinking, well, 16 pi over 16 would be pi. So I am short 1 pi 16 of a half a turn. Remember, pi is a half a turn. And this is positive. So as I go to graph this, I have my initial side on the positive x-axis. I rotate around. Now I'm going to have to make it a little bit bigger than it really is, just so that I have some room to work with it. So 15 pi 16ths is going to end up short of half of a turn. And once again, the reference angle has its vertex at the origin. The terminal side is one of the sides, and then it's use the positive x-axis or the negative x-axis, whatever creates an acute angle. In this case, it's going to be over here again, and this angle is my reference angle. Now I need the value of it. Well, if I take pi and subtract 15 pi 16ths, I have a 1 pi 16ths, and that is my reference angle. This value in here, this angle, is 1 pi 16th short of a half a turn. So that's my reference angle. So my theta prime is pi 16ths. So there's a little bit of work with fractions in there. 5 pi thirds? Well, I'm thinking of that as 3 pi thirds plus an additional 2 pi thirds. So it's a half a turn and 2 more sets of 60. Or I'm 1 pi third short of a full rotation. So that's going to end up in quadrant 4. So here's my initial side. And as I rotate around, I end up 60 degrees, 1 pi third short of a full rotation. So here's my 5 pi thirds. Now, for the reference angle, it uses the vertex, it uses the terminal side, and then the x-axis, not the y-axis, never the vertical y-axis. It's always either the positive to the right, the axis going to the right, or the axis going to the left. And it's the one that creates an acute angle. So it's going to be the positive x-axis. And this right here, that's an acute angle formed by the terminal side and that positive x-axis. And the value of that is going to be our reference angle. Well, we were pi thirds short of a full rotation, and that reference angle is pi thirds. So theta prime. Reference angles are important. Then we have 490 degrees, which I'm thinking is 360 degrees, plus, if I subtract 360 from that, I'm 130 degrees beyond a full rotation. So that's going to put me in quadrant 2. So I'm going from here, I'm doing a full rotation in 130 degrees. It's not 135, somewhere around there. And so my reference angle uses the vertex, or its vertex is the origin, and the terminal side is one side of it, but then I need it to be used with the x-axis, either to the right or to the left. That creates an acute angle, and it's to the left. And this angle right in here is my reference angle. And so I'm thinking, oh, well, if I take 180 degrees and subtract 130, I get 50. I'm 50 degrees away from that turn of 180. That is my reference angle. So theta prime is 50 degrees. Make sure you put the degree symbol when it's degrees. I realized that I kind of left off one that ends in quadrant 3, so I'm just going to do a quick, what if we had 200 degrees? Well, 200 degrees is 180 degrees plus an additional 20. We're going 20 degrees beyond. So if I rotate around, I end up here. And I kind of did this backwards, so I'll switch the colors up. There's my vertex. There is my terminal side. And I need the x-axis that will create an acute angle with it. And so that's the negative. And so this being 20 degrees is that reference angle for that. So that reference angle for this one is 20 degrees. Reference angles are always positive and always acute, between 0 and 90 or between 0 and pi halves. All right, then a quick little review from geometry. I just wanted to go through angle of depression and angle of elevation. So it shows if you look at a point above you, you're standing at the ground, such as the top of a building. The angle that your line of sight makes with a line parallel to the ground is called the angle of elevation. And from the top of the building, a line parallel to the ground, if you look down, that is your angle of depression. So this is your angle of depression. Sometimes people get it mixed up and they think it's inside the triangle. It isn't. And then here's your angle of elevation. And the whole idea from geometry is, since they're parallel, those are alternate interior angles, and the angle of elevation, is congruent to the angle of depression. So we have a parasailer is attached to a boat with a rope 80 feet long. So we're going to have a nice little boat. There's my boat. It's as good as it's going to get in the water. And then you've got a person who is parasailing. So there's the parasail. Boy, I'm such an artist. We're going to pretend like, we've got a right triangle here. It's not a very windy day, I guess. But anyway, so now you have to be careful. Think about, the rope is 80 feet long. Well, that's this length. It's not the water length or the altitude that the parasailer is. Now, the angle of elevation from the boat, so from the boat to the parasailer, is 31 degrees. So that's this one right here. Estimate the parasailer's height above the boat. Really, they mean altitude above the water. And so there it is. You're going to need a calculator. And so you need to set up and think about, if I have 31 degrees, and I'm going to use that angle, then H is the leg opposite, 80 is your hypotenuse. So what works with opposite and hypotenuse? And it is sine. So write sine of 31, put the degree in there, is the opposite over the hypotenuse. Multiply both sides by 80. You can put this all just in your calculator just like that. Make sure your calculator is in degree mode. And then just multiply it out and to the nearest tenth. So that height is approximately 41.2 and include units. So a couple problems on that. So there you have it.